So I'm going to talk about the program we launched in September this year. And it's going to be a bit continuation of what we just discussed in the last session about the value of certificate programs and interdisciplinary approach. So this is all what we did. Before I go, Fariba and Parisa are my PhD students in the lab, and they are involved in this program, and they also teach in the program. So I just wanted to acknowledge them. Okay. So we started, before I go into the details, I'm from Canada, yet again. What's new? I don't speak French, and I'm new in Canada, just moved 5 years ago. And my first job in Ryerson was, I was in the business school and heading one of the departments which has 1,500 undergrad students. And at the time, 28 full-time faculty members. And my background is, 15 years ago, I was in industry and switched back to academia. And when I was talking about universities, curricula, and all that, I was talking just like you guys in IBM, criticizing the universities being totally outdated and slow and all that stuff. Once I switched, I understood that that was for a good reason, that universities are slow, especially when it comes to undergrad program design and curriculum design, because university education means that we teach people, not professions, we teach them to solve problems, to be able to think critically, and also we want to make sure that anything we teach would still be basic stuff, would still be relevant 20, 30 years from now, and we will teach them how to learn rather than, specific current profession. So that's why, it's difficult to change curricula overnight. And if you want to be relevant and keep up with the needs of the marketplace, certificates or masters are easier and, quicker turnarounds in that respect. And then while doing that, university learns how to do it, and then simultaneously reflects in its current undergrad curricula as well. So that was the reasoning. And also, for me, it was very difficult to understand and enjoy tenure system coming from industry, that, having a lifetime job guarantee at a university. And also, in the Canadian system, having very strong unions, as a manager at a university, your hands are totally cuffed unless, the faculty member is really willing and engaged to do anything differently. So, as a university, you need to come up with alternative ways of addressing the needs in the industry. So, this was part of the motivation, and also, the subject matter, as we all know, is very critical and important. And in the Canadian marketplace, we have a shortage of skills, and everybody is looking for these skill sets, etc. So these were some of the numbers that supported, our proposal in terms of the need in Canada and globally, etc. So I'll just go over it. So we wanted to target people who are professionals in this program, so who had education in different fields, who wanted to convert themselves to this field, or who had been, who have been working in some sort of data science or business analysis types of jobs that they needed, extra skills, or fresh graduates who really wanted to get a job in this field. And this is a picture from Oracle's white paper in 2013. This shows basically the hierarchy of knowledge in the organization, not necessarily the organizational hierarchy. So we have knowledge-driven business processes where we had lots of automation in the area of, ERPs, etc. And then we have some reporting systems which give information about our customers, etc. And then we have dynamic dashboards and reports where the business analyst comes into the picture who, analyzes that. And then we create new knowledge by discovering the knowledge. That's where your data scientists and data analytics people come. And then they inform the business executives to make strategic decisions and run the organization. So when we looked at our own programs in Ryerson, we had been providing all sorts of programs at the bottom of the spectrum, in the business school, in science, engineering, everything. So especially when I headed that department, Information Technology Management, I managed to change the whole curriculum to make it, to groom people who would become business analysts in the marketplace. So the next step, the next logical step for us was to provide the next knowledge level that would be needed in the industry. So that's where our certificate is aimed at. And once people take and graduate from the certificate, they would be able to work in these jobs. Again, if you look at, it's not one title, one area, it's a spectrum of people. So I have a different view of what, some of the discussions were in the last session about the, tools. I think we all need to agree and understand how we define business analytics. So if we are defining business analytics somewhere around here, yes, we need tools and we don't need any other sophistication. So if we are defining business analytics one level above, so we really need some sophisticated knowledge and algorithms of math, statistics, machine learning, database technologies, etc. So we cannot possibly provide those in business schools. They can be part of the offering, and they can learn how to interpret those numbers and make decisions, but they cannot be the maker of those numbers. And I've been doing machine learning research since 1987. And as Jerry pointed out, it used to be expert systems, intelligent systems, and all that. Now we call them recommender systems and, data analytics, so on and so forth. So thank God we still have very serious research challenges that keeps me in the job, that machine learning hasn't solved all the problems that, we can rely on the machines totally and just turn around and walk away. So I'll go back to my analogy of the surgeon. We have a lot of AI tools, robots in the operation room. And yes, we can maybe eliminate some of the functions, some of the tasks the surgeon does, or instead of 5 surgeons, maybe we need 1. But we really need that one surgeon who is a surgeon, not the robot. So if we want to target upper levels, you really need to know how to make those numbers. You can't just get a black box and rely on that black box. It's like, I drive a car, I don't need to know how the engine is built. In this thing, I didn't need to know how the engine is built. I just can't drive the car like that. And it is very dangerous to me and very scary that, especially when data is so big, there is a huge risk of generating garbage in, garbage out. So you really need to talk the data, sense the data, and know the data. It's very, very important. So I'm I feel very strongly about that. And so I think as a community, especially in academia and in industry who spends a lot of research on that, we really need to be very careful, when we define what we are talking about. So for maybe, majority of the companies, we won't need this sophistication, but for a few, we really need that. Anyway, so again, referring to yesterday's talks, we also follow the same path in terms of how we could develop this certificate program to match with the competencies needed in the industry. So when it comes to continuing education, again, personally, I believe that why would anybody should come to a university and get a university branded certificate, unless that university is MIT, Stanford, or so forth. So I think it's important that you align yourself with a well-known international body who gives certification. And then, you know, when you look at all the ads in the marketplace, they will be looking for X certificate, Y certificate, knowledge of this and that, maybe products or, you know, well-known certifications. So that's why we used Informs, which is the only professional certification in data analytics right now. We aligned ourselves with this certification called CAP, Certified Analytics Professional. So they launched this certification 18 months ago. There's an exam. And there are also certain conditions that anybody who takes this exam has to come from at least 5 years of hands-on analytics experience in the industry. And then once they pass the exam, they have to keep currency periodically by either taking courses or, you know, showing other currency requirements. So basically, they look at 7 domains in terms of competencies that a business analytics person should have. They look at how business problem forming, you know, they understand how to frame the business problems. And then taking the business problems, how they can formulate the analytics problems. Because we have a business problem and we have all kinds of solutions, maybe tools, algorithms, etc. How are they going to know which one is the most suitable for this given problem? And they need to understand how to manage and retrieve data, use a methodology in solving these problems, build models, deploy these models, and then make it a life cycle management so that this is a continuous project within the organization. So this is how our curriculum is mapped to these competencies. We basically have 6 courses in the certificate. So if somebody is taking the certificate full-time, they can finish in 2 terms or in 12 months' time. So we have an introductory course where we address the process and the introduction to problem solving, etc. We have a course in data management, and we have 2 courses. One is basic statistics, the other one is introductory machine learning course. And we teach the analytics tools, such as Hadoops, Hives, and all that. In the basic methods course, we teach to program in R. And we have a capstone project where they go out with a company and tackle a real-life analytics project by applying all the knowledge they learned in the certificate.
Are these 3 credit hour courses?
Sorry?
They are 3 credit hour courses?
Yes, they are 3 credit hour courses, exactly. And currently we started in fall 2014. Actually, we were quite late, of course, in the approvals and all that. And we had our first marketing event mid-May and the second one in mid-June. And we have 180 people registered in the program currently. And we are offering the first 3 courses this term. And this certificate is an interdisciplinary certificate. And it's, although it's housed in the engineering faculty, we have teaching departments from Faculty of Science, Mathematics, and Computer Science. So it's a combination of industrial engineering, mathematics, and computer science. And we have 2 coordinators. I'm one, and I have a fellow coordinator in computer science. And we have a standing curriculum committee from business school as well as the other faculties. So far, in terms of interdisciplinary and management, it works quite well. I get along very well with my co-coordinator and all the other people. Maybe, I don't know, I may be a dominant character that they say yes. I have no idea. But it works quite well. We have no issues. And of course, it helps that senior management buy-in, as always, is very important within the university. Our provost wants to leave a legacy of interdisciplinary, programs and work. So we have 100% of his support. It helps a lot. So why we did this in Ryerson? Because last year, Ryerson took Big Data Initiative, as we call it, BDI, as one of its strategic priorities. In Ontario, we have universities are required to differentiate themselves from each other, and it's called strategic mandate agreement. So each university has to prepare one of those, and that's how our budgets are given by the government. So if you cannot do that, you don't get budget basically. So it's part of our strategic mandate agreement, and it's part of our new academic plan that is launched this fall. And we have a variety of projects and collaborations. So we have collaborations with incubators. We've just established a Big Data and Privacy Institute where the previous Ontario Privacy Commissioner, Anne Kovukian, is leading as the executive director of it. And we are working on another institute, Tools and Applications. We have existing research centers, including mine and the high computing facility. We have just become partners in SOSIP. And we have, apart from this program, in fall 2015, we are working on to launch a Master of Science in Data Science and Analytics. And also, as we speak, in many of our undergrad programs currently, we are converting some of our existing courses to data science and analytic courses, and some of our departments are considering specializations in their current curricula. And we also, this week, will be launching a Canadian Big Data Analytics Talent Gap Analysis project. One of our partners is Simon Fraser and Fred. We are working together. So the new program that we are talking about is even more interdisciplinary. It's a pan-university program. And now this program is going to be housed in School of Graduate Studies, and the Engineering, Science, Business, Faculty of Communication and Design, and Faculty of Arts are all partners, and they are committed. So now I have a curriculum committee even more diverse, coming from representatives from each faculty, and as I said, they are all committed. Why? Because I think I said yesterday that I see this data scientist job and the data scientist function as a team of people rather than one single person. So it really reflects the commitment and the various areas of application in real life that we need that kind of an interdisciplinary approach. So what's new in that? We keep talking the same thing over and over, maybe since '87. So when I did my master's in Huntsville, Alabama, I was employed at NASA and working with engineers who built the spacecrafts. And we had a very interdisciplinary team, including psychology people. And I was shocked, why those guys were involved in that. So since then, we forgot some of these knowledge, unfortunately, and went all of our own ways. Now I think maybe it's time to get back and acknowledge that we each contribute to building such complicated systems or programs or education that we really need to work together. And we really need to be diverse in the team formations. Thank you.